In this question, we have to find the value of 1 plus I raised to 5 into 1 minus I raised to 5. Or we can say we have 4 raised to 5 of 1 plus I and 1 minus I, which is actually in the form of A plus B into A minus B, which is equal to A square minus B square. So we can say within the bracket we will have 1 square minus I square. Now we know that your 1 square is nothing but 1 and your I square is minus 1 whole raised to 5. So 1 minus of minus 1 will become 2 raised to 5, or we can say 32, which is given in option D. Ta-da! In this question, you have to find real part of 1 plus I whole raised to 2 upon 3I. So first of all, let's simplify our complex number. First of all, we have to simplify our numerator, which is in the form of A plus B the whole square, which can be expanded as A square plus 2AB plus B square. So our numerator will become 1 square plus 2 times A into B, which is 1 and I, plus B square, or we can say I square. And your denominator still remains as it is. In further simplification, we can say 1 plus 2I, and the value of I square is nothing but minus 1 upon 3 minus I will remain as it is. Now in numerator 1 will cancel out, we will get 2I. Now to remove the complex number in the denominator, we have to multiply and divide its conjugate. So let's multiply and divide by 3 plus I. So let's just ignore this minus 1 and plus 1. Now your 2I will multiply with 3 will give us 6I, and 2I multiply with I will give us 2I square. In denominator we have A minus B and A plus B, which will give us A square minus B square, or we can say 3 square minus I square. So here we'll get 6I, and this I square will become minus 1. So here we'll get minus 2 upon 3 square will be 9, and this I square will be minus 1. So we'll get 9 plus 1, or we can say 10. So your Z will be minus 2 by 10 plus 6I by 10, or we can say minus 1 by 5 plus 3 by 5 I. But as you know, we have to find out the real part of the Z, which is minus 1 by 5, which is given in option A. Ta-da! In this question, we have an equation with the complex number. Our equation is 1 minus I into X plus 1 plus I into Y is equal to 1 minus 3I. Now, let's simplify our equation by opening all the brackets. This X will multiply with 1 will give us X, and X multiply with minus I will give us minus Xi, plus this Y multiply with 1 will give us Y, and Y multiply with I will give us Yi, is equal to our right hand side will be remain as it is. On left hand side, let's collect the real parts, which is X and Y. So let's write down X plus Y, and your imaginary part will be minus X plus Y. So if we take I common, we will get minus X plus Y is equal to 1 minus 3I. So let's compare real part. The real part of the left hand side, which is x plus y, must be equal to real part of the right hand side, which is 1. Similarly, it's time to compare imaginary part. So we can say the imaginary part of the left hand side must be equal to imaginary part of right hand side, which is minus 3. So here we get two equations, x plus y equal to 1 is your first equation, and minus x plus y equal to minus 3 will be your second equation. To get the solution, let's add equation number 1 with equation number 2. So first of all, let's get your first equation, then your second equation. Now, if we add these two equations, your x will be cancelled out, y plus y will become 2y, and 1 minus 3 will be minus 2. So your y will be minus 1. And let's substitute this value of y in first equation. So we will get x plus y, or we can say x minus 1 will be 1, which will give us x is equal to 2. So your final answer is x is equal to 2 and y is equal to minus 1, which is given in option A. Ta-da! In this question, we have to simplify under root of 5 plus 12i plus under root of 5 minus 12i upon under root of 5 plus 12i minus under root of 5 minus 12i. Now, to simplify this complex number, we have to multiply and divide by conjugate of the denominator, which is under root of 5 plus 12i plus under root of 5 minus 12i. Same thing, you have to multiply with the numerator. So here in numerator we get a plus b the whole square, which can be expanded as a square plus b square plus 2ab. So in numerator we will get square of under root of a, which is 5 plus 12i, plus square of b, which is under root of 5 minus 12i, plus 2 times ab. Your a is 5 plus 12i and your b is under root of 5 minus 12i. And in denominator we have a minus b and a plus b, which will be simplified as a square minus b square. So we will get square of your a, which is under root of 5 plus 12i, minus the square of b, which is under root of 5 minus 12i. In further simplification, we can say square and root will cancel out and we will get 5 plus 12i, plus in second term we will get 5 minus 12i, plus 2 times we have under root of a plus b and a minus b. So we can say we have 5 square minus 12i the whole square, which will become minus 144. So here we'll get plus 144 and your 5 square will be 25. And in denominator we will get 5 plus 12i minus 5 minus 12i, or we can say minus 5 plus 12i. Now let's further simplify. This 12i will cancel out. 5 plus 5 will become 10, plus this under root of 25 plus 1, 44 will become 13 and 13 twos are 26. In denominator, your 5 will cancel out. 12i plus 12i will become 24i. So here 10 plus 26 will become 36 upon 24i, or we can say 3 upon 2y. But as we know, 1 upon I is nothing but minus I. So your final answer is minus 3i by 2, which is given in option A. Ta-da! In this question, we have to get 2i upon 1 plus I the whole square. To simplify this, let's expand. In numerator, we will get 2i square, or we can say 4i square, and in denominator, we will get 1 plus I the whole square, which will give us 1 plus 2i plus I square. So, in numerator, we will get minus 4, and in denominator, this I square will become minus 1. So, this 1 and minus 1 will cancel out, and remaining term will be 2i. So, 2 2s are 4 will give us minus 2, and this 1 upon I will become minus I. So, your required complex number is 2i, which is given in option B. Ta-da! In this question, you have to find imaginary part of 1 plus I the whole square upon 2y. So let's simplify. In numerator, we have a plus b the whole square, which can be expanded as a square plus b square plus 2ab. So in numerator, we will get 1 square plus I square plus 2 times ab, which is 1 and I, upon 2 minus I will be as it is. Now as we know, this I square is minus 1. So 1 and minus 1 will cancel out, and in numerator, the only remaining term is 2i, upon we have 2 minus I. In further simplification, you have to multiply and divide by conjugate of the denominator, which is 2 plus I. So, in numerator, 2i will multiply with 2 will give us 4i, and 2i multiply with I will give us 2i square, upon in denominator we have a minus b and a plus b form. So, we will get 2 square minus I square. So, our complex number can be simplified as 4i, then this 2i square will become minus 2 upon 2 square, which will become 4, and I square, which will become minus 1. So, here we will get 4 plus 1, or we can say 5. So, your complex number is minus 2 by 5 plus 4 by 5 of I. But as you remember, you have to find out imaginary part of that, which is 4 by 5, given in option C. Ta-da! In this question, we have to simplify and get our required complex number. So, let's simplify one by one. Let's say your first complex number is z1. So, let's say your z1 is 1 minus 2i upon 2 plus I. Now, to simplify this thing, let's multiply and divide by conjugate of the denominator. So, we have to multiply and divide by 2 minus I. So, in numerator, we have to multiply 1 with 2 will give us 2. 1 minus I is a minus I. Then minus 2i into 2 will give us minus 4i, and minus 2 into minus I will give us plus 2i square. In denominator, we have a plus b into a minus b form, which will give us a square minus b square, or we can say 4 minus I square. Now let's substitute the value of I square and simplify. In numerator, this 2I square will become minus 2. So we can say this 2 and minus 2 will cancel out, and minus I minus 4I will become minus 5I. Similarly, in denominator, this I square will become minus I, so we will get 4 plus I, which will give us 5. So here, your Z1 is nothing but minus I. Similarly, let's try to simplify our Z2, which is 4 minus I upon 3 plus 2I. And as we know, to simplify this, let's multiply and divide by conjugate of the denominator, which is 3 minus 2y. Now, let's simplify. This 4 will multiply with 3 will give us 12. 4 multiply with minus 2y will give us minus 8i. Now, minus I multiply with 3 will give us minus 3i. And minus I into minus 2i will give us plus 2y square. Upon, in denominator we have a plus b and a minus b form, which will give us a square minus b square. So, in further simplification, we can say this 2y square will become minus 2 and plus 12 minus 2y will become 10, and this minus 8i and minus 3i will become minus 11i, and in your denominator we will get 9 plus 4, or we can say 13. So here we get our Z2 as 10 by 13 and minus 11 by 13i. But if you remember, we have to get the complex number Z, which is equal to Z1 plus Z2. So your first term is your Z1, which is minus I, plus your second term is Z2, which is 10 by 13 minus 11 by 39. Now, let's get into the standard form. Your real part is 10 by 13, and to get the imaginary part, you have to take summation of minus I and minus 11 by 39, which will give us minus 24 by 39. So, tada! This is your required complex number, which is given in option D. In this question, you have to find x and y, which are the real numbers, satisfied this equation, which is x plus iy into 3 plus 2y is equal to 1 plus I. In this equation, we have advantage that x plus iy is in the one term. So, we can easily make x plus iy subjective. So, x plus iy will be equal to 1 plus I upon 3 plus 2y. Now we just have to simplify this complex number and get x and y from the real as well as imaginary part by multiplying and divide by conjugate of the denominator, which is 3 minus 2y. Now let's get our numerator. 1 multiply with 3 will give us 3. 1 multiply with minus 2y will give us minus 2y. Now let's multiply I with the 3 will give us 3i, and I into minus 2i will give us minus 2y square. In denominator we have a plus b and a minus b form, which will give us 3 square minus 2i the whole square. So we can further simplify by taking this minus 2y square as a plus 2. So 3 plus 2 will give us 5, and minus 3i and plus 3i will give us plus I. In denominator, we will get 9 plus 4, or we can say 13. So, To get the standard form, let's get individual denominator. So we'll get minus 5 by 13 and 1 by 13, which is equal to x plus iy. So if we compare the real parts on the both sides, we will get x is equal to 5 by 13, and from the imaginary part, we will get y is equal to 1 by 13, which is given in option C. Ta-da! Here, you have to solve 3 minus 2yi is equal to 9 raised to x minus 7i and get the value of x and y. To get the value of x and y, you have to compare real part and imaginary part. Now, real part of the left hand side is 3 must be equal to real part of the right hand side of the equation, which is 9 raised to x. Or we can say 3 raised to 2x must be equal to 3 raised to 1. Now we can compare the power of 3 on both sides. So we can say we will get 1 is equal to 2x, or x is equal to 1 by 2, or we can say 0.5. Similarly, let's compare imaginary part. On left hand side, your imaginary part is minus 2y must be equal to the imaginary part of right hand side, which is minus 7. So minus minus will cancel out and you will get y is equal to 7 by 2, or we can say your y is simply 3.5. So your final answer is x is equal to 0.5 and y is equal to 3.5, which is given in option A. Ta-da! Here, you have to find out that complex number 1 plus 2i upon 1 minus I lies in which quadrant of the complex plane. So, first of all, let's simplify our complex number, which is 1 plus 2i upon 1 minus I. And for that, we have to multiply and divide by conjugate of the denominator, which is 1 plus I. So let's multiply. 1 with 1 will give us 1. Then 1 multiply with I will give us I. Then 2i multiply with 1 will give us 2i, and 2i into I will give us 2i square. And in denominator we have a minus b and a plus b form, which will give us a square minus b square form. In further simplification, we can say this 2i square will become minus 2. So, this minus 2 plus 1 will give us minus 1. And this I plus 2i will become 3i. Now, in denominator, we will get 1 plus 1, or we can say 2. So, let's give individual denominator. So, your z is minus 1 by 2 and plus 3i by 2, or we can say the real part of z is minus 1 by 2, which is less than 0, and imaginary part of z is 3 by 2, which is greater than 0. Your real part is negative and imaginary part is positive, so we can say our complex number lies in second quadrant of the complex plane, which is given in option B. Ta-da! Here it is given that 1 plus I upon 1 minus I raised to m is equal to 1. Then we have to find the least integer value of m. So to get the value of m, let's simplify our complex number 1 plus I upon 1 minus I. And for that, we have to multiply and divide by conjugate of the denominator, which is 1 plus I. So, in numerator, we will get 1 ones are 1, 1 i's are I ones are I, and i's are I square. And in denominator, we have a minus b into a plus b form, which will become 1 square minus I square. In further simplification, we can say your I square will become minus 1. So 1 minus 1 will cancel out and this I plus I will become 2i. In denominator, we will get 1 plus 1, or we can say 2. So your complex number is simply I. But it is given that z raised to m is equal to 1 and we get our z is equal to I. So I raised to m must be 1. As we know, your I raised to 4 is also 1. So we can say the least integer value of m can be 4, which is given in option B. Ta-da! In this question, we have to find 1 plus I upon 1 minus I the whole square plus 1 minus I upon 1 plus I the whole square. So 1 by 1, let's simplify. Let's say this 1 plus I upon 1 minus I is z1. Now, to simplify this, we have to multiply and divide by conjugate of the denominator, which is 1 plus I. So here we'll get 1 square plus 2i plus I square upon, in denominator we have a minus b and a plus b, or we can say 1 square minus I square. So this I square and 1 will be cancelled out and we will get 2i. And in denominator we will get 1 minus minus 1, or we can say plus 1. So your z1 is simply I. Similarly, we can simplify our second complex number, which is considered as z2. And to simplify this, we will do the same thing. We will multiply and divide by conjugate of the denominator. So this time we will get 1 square minus 2i plus I square. And in denominator we will get 1 square minus I square. So this I square and 1 will cancel out. We will get minus 2i upon 2, or we can say minus I. But we need to find out z1 square plus z2 square. As we know, your z1 is I. So here we have to get I square plus your z2 is minus I. So let's write down minus I the whole square. Now I square will be minus 1 plus, due to the square, minus will be plus 1, and your I square is still minus 1. So minus 1 will become minus 2, which is given in option C. Ta-da! In this question, we have to find smallest positive integer number of n, which satisfied 1 plus I raised to 2n is equal to 1 minus I raised to 2n. So, to simplify this, let's say whole raised to 2n 1 plus I upon 1 minus I will be equal to 1. Now, as we know, 1 plus I upon 1 minus I can be simplified as I. So, here we'll get I raised to 2n is equal to 1, which can be rewritten as I raised to 4. So, by comparing the power of I, we can say your 2n must be equal to 4. So, we will get n is equal to 2, which is given in option B. Ta-da! Here, it is given that 1 minus I upon 1 plus I raised to 100 is equal to a plus ib, and we have to find the value of a and b. No problem. First of all, let's simplify the complex number within the bracket. Let's say it is your z. So your z will be 1 minus I upon 1 plus I. Now, to simplify this, we have to multiply and divide by conjugate of the denominator, which is 1 minus I. So, in numerator, we will have the whole square of 1 minus I, which can be expanded as 1 square minus 2ab plus b square, or we can say I square. And in denominator, we will have a plus b into a minus b, which can be simplified as 1 square minus I square. In further simplification, we can say your I square is nothing but minus 1. So this 1 and minus 1 will cancel out and we will get minus 2y. In denominator, this I square will be replaced by minus 1. So we will get 1 minus minus 1, or we can say 2. So this 2 will cancel out and your z1 will be minus I. But it is given that z raised to 100 is equal to a plus ib. Our z is nothing but minus I raised to 100. So we can say a plus ib is simply minus 1 raised to 100 into I raised to 100. Minus 1 raised to 100, 1, and I raised to 100 can be rewritten as I raised to 4 whole raised to 25, which will give us 1. So we can say on right hand side we have 1 plus 0i. By comparing real parts, we will get a is equal to 1, and by comparing imaginary part, we will get b is equal to 0, which is given in option B. Ta-da! In this question, you have to find 1 plus I raised to 10. If we expand directly, then we will get 11 terms. So, to simplify this, let's rewrite as 1 plus I the whole square whole raised to 5. Now, let's expand this using the expansion of a plus b the whole square, which is nothing but a square plus 2 times ab plus b square. So, here we'll get 1 square plus 2 times 1 into I plus I square whole raised to 5. Now, in further simplification, we can say 1 square is nothing but 1 plus your middle term will become 2i and your I square is simply minus 1 whole raised to 5. Now, here 1 minus 1 can be cancelled out and we will get 2 raised to 5 into I raised to 5. Your 2 raised to 5 is simply 32 and I raised to 5 is I. So our required complex number is 32i, which is given in option A. Ta-da! In this question, you have to find the value of 1 plus I whole raised to 6 plus 1 minus I whole raised to 6. Now, if we expand these two terms, we will get very lengthy step. So, let's say we just have to find out 1 plus I the whole square whole raised to 3 plus 1 minus I the whole square whole raised to 3. Now, as we know, 1 plus I the whole square is simply 2i. So, we'll get 2i cube plus 1 minus I the whole square is minus 2i whole cube. So, here we get 2 cube into I cube minus 2 cube into I cube, which will become 0, which is your required complex number given in option A. Ta-da! It is given that the conjugate of this first complex number is equal to your second complex number z2. So here we'll get z1 is equal to z2 bar. Now, as we know, your z1 is simply x plus iy into 1 minus 2y, and z2 bar, which is conjugate of z2, will be 1 minus I. For simplification, if we take 1 minus 2i on the right hand side, we will get 1 minus I upon 1 minus 2y, which is given in option C. Ta-da! In this question, we have to find conjugate of 2 minus 3i upon 4 minus I. So, to get the conjugate, let's simplify our complex number by multiply and divide by conjugate of the denominator, which is 4 plus I. So, 2 will multiply with 4 will give us 8 and 2y is a plus 2y. Now, it's time to multiply minus 3i with 4 will give us minus 12i and minus 3i into I will give us minus 3i square. And in denominator, we will have a minus b into a plus b, which will give us 4 square minus I square. So, our complex number will be simplified as this 8 and minus 3i square will become plus 3. So, 8 plus 3 will be 11. And remaining two terms, which is 2i and minus 12i, will become minus 10i. And in denominator, we will get 16 plus 1, or we can say 17. This is not your answer, this is your complex number. And your answer is conjugate of this complex number, which is 11 plus 10i upon 17, given in option B. Ta-da! Here we have one simple question. We just have to find out the conjugate of 1 plus I. So, to get the conjugate, we just have to replace your I with minus I. So, 1 minus I is your answer, which is given in option C. Ta-da! I hope you guys enjoy the video. To get full marks, keep hard working and keep smiling. Bye-bye.